All right. I think we got most people on, so we'll get started. People will still be rolling in over the next few minutes, but that's okay. All right. Well, good morning, everyone. My name is Nicholas. I'm Director of Customer Success at Hortow. And today I'll be joined by Travis in this webinar to go over post-harvest irrigation management and the best practices, and it should be pretty exciting. So without further ado, Travis, I will let you take over.
Hey, well, thank you, Nick. Appreciate you bringing me in, and good morning, everyone. My name is Travis Goldman. I'm the Irrigation Management Advisor for Hortow, and today we'll be discussing post-harvest irrigation management. We'll be discussing why post-harvest irrigation matters. We'll be looking at the best irrigation management practices for strategically reintroducing water into our soil and utilizing Hortow's 1K sensor for proactive irrigation management. At the end of my discussion, we'll be opening up the webinar to questions, so feel free to insert questions into the chat, and I'll be more than glad to answer those at the end. The big question that brought everyone here today is, well, why do we irrigate after harvest? And that answer is that we're building the energy required for next year's bloom. As far as this critical window after harvest and before dormancy is where our trees and vines are going to be storing starches and vegetative wood and roots. This stored energy is going to be used for our trees and vines before the leaves can contribute and support mass flow during basically our bloom and during cell division. Having high stress after harvest and before dormancy can dramatically hurt carbohydrate sequestration and dramatically hurt the amount of stored energy that we have in our spurs. Now, this stress can come from not just irrigation, but all three pillars in our agronomic triangle. When we're looking at this, we're trying to make sure that we're mitigating stress with irrigation, nutrition, and pest control. As far as with post-harvest irrigation, we're still trying to minimize our downtime by making sure that we're not getting our trees and vines too wet as well as too dry. We're trying to make sure that we're optimizing our plant water uptake to make sure that the nutrients are going to be coming into the plant and going to be able to be converted into the stored energy within the wood. As far as with irrigation practices, we're really trying to make sure that we're mitigating long-term repercussions of stress by making sure that we're not getting our trees too wet before they go dormant, as well as that we're not just causing them to desiccate out and really kind of shut things down. And as far as overall post-harvest irrigation, we're really trying to make sure that we're managing our application through our distribution uniformity. We're making sure that we're properly maintaining our irrigation system, as well as that we're applying water evenly throughout that field. The key role with applying water after harvest is that we're trying to make sure that we're reinstating this partial pressure between our leaf and our soil. We're trying to make sure that transpiration continues. And as far as that, we're overall, our nutrition, our water uptake is going to be continuing, and we're also continuing photosynthesis. The big thing is transpiration. Now, post-harvest, we know that we have majority of our soils are dried down to where water is no longer necessarily available to the tree or even to the vine. By applying water in a balanced way, we're making sure that we're stabilizing our soils and making sure that our nutrition program and water is reinstated and available back to the tree or to the vine. But it's not as simple as just adding water. During this time, water can also be your biggest enemy. We're trying to make sure that we're not creating mud and we're not creating this downtime. Just simply applying water can become a really big problem. It can compromise our transpiration rate of our tree or of our vine simply because it's removing oxygen out of our soil profile. At this time too, by having this downtime and having these anaerobic conditions, disease pressure can be vastly expressed as far as with especially your soil-borne diseases. Now, post-harvest, this is a time that, distribution uniformity is as critical before we take our crop off as it is after. We're trying to make sure that we have proper distribution uniformity throughout the whole season, that we're applying water evenly throughout the field. In that post-harvest, we're making sure that we're flushing lines, we're chemically treating lines, especially if it's needed, with biologics or precipitates that are starting to accumulate. And overall, too, we're trying to make sure that we're repairing any kind of damaged components. This can vastly hurt our ability to rehydrate the soil profile. Now, soil rehydration, it becomes difficult without the right tools. Looking at this field, we can see the top line through distribution uniformity tests that it's actually meeting the output requirements. Is that line in itself, it's putting out 0.53 gallons per emitter, and we're actually receiving that 0.04 inches of water per hour. But in a compromised line that has biological growth and other precipitates that are starting to accumulate within that emitter, we're actually noticing it's about 0.30 gallons per hour out of that emitter, and vastly reducing our output. What we're starting to see, if you were to do a 24-hour run under a normal irrigation, we should see something just under an inch. But with these holes, we're starting to see some areas getting just over a half an inch. What we're trying to do with post-harvest maintenance is that we're trying to make sure that we're eliminating these voids and eliminating these holes, and we're making sure that we're evenly applying our water and we're even applying our fertility program as well. Now, when I'm talking about nutrition, as far as nutrition is a really critical role for post-harvest, because it's really helping us out with soil rehydration and imbalance in our soils. At this point in time, we're looking at our soil and our tissue samples and figuring out where our voids are with both our micronutrients and our macronutrients. At this point in time, post-harvest, we're putting on bulk soil amendments to make sure that we're correcting any type of issues with these larger deficits with either potassium or calcium or even sulfur, with correcting kind of the pH. Now, everyone's familiar with mass flow, but if we don't have our nutrition program in our soil, it's going to be really difficult, even with proper irrigation, to get those essential nutrients to help out with supporting that tree or that vine until dormancy. At this point in time, with proper irrigation and proper nutrition, we're going to make sure that we're continuing that flow of energy, or of the building blocks to build that energy before the tree or the vine goes dormant. Now, during post-harvest, we're looking at applying these soil amendments and these nutrients within a reasonable amount of time. We're applying them before the tree or the vine goes dormant. We're replenishing these nutrient deficits, as well as at this time, we're able to help balance the pH of the field. This is a great time to help correct water penetration issues, especially something that starts to creep up on us as we get towards harvest. This is something that we can apply materials in bulk to help out with this and to help out overall with standing water potentially even after dormancy, or into dormancy, I should say, and into the wintertime. This pillar is key for irrigation success. As far as with soil rehydration, if this pillar is lacking, it vastly hurts irrigation, hands down. Now, with the third pillar, we're looking at pest control. At this time, what I'm really doing is I'm assessing my canopy. I'm looking at how much of it has been lost after harvest. Not every year is the same, and especially trees and vines under stress, they transpire differently. They're hurt. They won't pick up water as much as they could potentially with a full canopy. And you really have to put that into understanding of how to manage that field. As well, with knowing that you're going to have different levels of transpiration because of pest or disease issues, you need to make sure that you're mitigating long-term repercussions of stress and making sure you're not getting those trees or those vines too wet. Now, after harvest, we're dealing with very dry soils, and what that can do is it can definitely, start to see the your canopy become stressed out. It starts to express stress because the stomata begin to close down, and essentially the tree is trying to mitigate turgor pressure by closing down this whole system. By reintroducing water properly, we can help really reduce that amount of stress that's going to be shown and present inside the canopy itself. Now, really looking at this, not every year is the same. Every year is different. Now, looking at this orchard, 2018 to 2020, you're going to have a completely different irrigation management strategy for post-harvest. When I'm looking at 2018 on my irrigation management plan, it's got to be adjusted. I can't just simply apply water, because when these trees get wet, guess what? They're going to stay wet. Well, in this situation for this year, we had mites during harvest. Reduce the canopy post-harvest. Just simply come in, you shake, you have a canopy that just got smoked by mites. You have a different basically role with your irrigation practices to make sure that you're supporting them without getting them too wet. At the same time as well, instead of just simply supporting this tree until it goes dormant, and allowing that time for carbohydrate sequestration to just send energy into the wood, it's actually utilizing our nutrition program to kind of do this regrowth in that canopy. In this point in time, you're going to see a little bit of vegetative regrowth, which isn't necessarily bad, but at the same time, whereas if you had a fully supported canopy, you could just completely have that tree or that vine devote that energy into building starches. Now, comparing this to 2020, there was a different mode of action that was used to control the mites before harvest. Through this, because of that lack of pest pressure, the canopy was retained through harvest and after harvest right now. And these trees have strong transpiration. When we're looking at strong transpirational gains, it means strong nutritional uptake and a lot of uptime. These trees are devoted to storing energy for vegetative wood in building that, that starch buildup inside those spurs for next year's crop. Now, overall, what we're trying to do in a farming situation is that we're trying to maximize photosynthesis from sun up to sundown. Now, post-harvest, we're dealing with shorter days, and we're dealing with a shorter window for this index of building energy for the plant. By making sure with proper irrigation, proper pest management, and proper nutrition, we can make sure that we're maximizing our uptime for photosynthesis by properly supporting the soil. Now, when I'm looking at a post-harvest management plan, I'm trying to really make sure that I'm narrowing down when I'm turning my water on and when I'm turning my water off. I think go into post-harvest, apply water, water's good, put them to bed, you're good to go. That really isn't the case. What you're running into is that you need to make sure that you're hitting that ideal window to make sure that you're optimizing transpiration during this time. Now, as far as with Hortal, we're using soil tension, so we're measuring a water potential, and what we're really doing in the field is we're measuring water availability. We're using 3 soil tension depths at 12, 24, and 36 inches. We're trying to make sure that we're recovering successfully our lateral water expansion, as well as we're taking care of that taproot to where we're not getting it too wet as well as too dry. I have to really hone in on this. Do not get things too wet. It's just as bad to be as wet as it is too dry during this time. Now, with tension, it's a direct measurement of plant stress. And through soil tension management, in monitoring it in real time, what we're noticing is that we're monitoring essentially like the heartbeat of our field. What we're seeing is that when we apply excessive water, things tend to stay wet because of a lack of oxygen. What we'd see is a shallower transpirational gain per day, the shallow heartbeat, and we see compromised transpiration. Once we have a balance, we don't have that neglect of oxygen in that soil. We have a well balance of water and oxygen. We can really begin to see adequate transpiration, especially in this graph. We can see at 12 inches, we're seeing that gain go through.
Travis, can
Yes,
I just stop you for a second?
you bet.
Do you mind explaining what this graph is for the people that may not be super familiar with the Horta platform?
Oh, you bet. As far as with this graph, we're looking at tension in a relationship of time, where our y-axis is our soil tension, our water availability, where 0 kPa is low tension, and 100 kPa in this example is high tension. For our ideal range, we want to make sure that we're within this optimum band of water and both oxygen availability. And as well as I'll be explaining these numbers a little bit more in detail in slides to go. Keying in off of optimum water, we're optimizing our transpiration rate. There's no plant stress, and we see a strong heartbeat. As water becomes a limited resource, we see an accelerated rate of loss. We start to see plant stress, and we also see regulated transpiration. So what do these numbers really mean? Well, if we look at 0 kPa, that's absolute full saturation. We've made mud, and that's something that we want to stay away from, especially post-harvest. At this point in time, no oxygen is present, and the soil cannot sustain this much water, and it will leach until it reaches field capacity. All micro and macro pores are completely full. Now, when we look at a balanced soil, we see that there is both a well balance of oxygen as well as water, as whether basically this plant is able to pick up water in a very even fashion. It improves transpiration, it improves nutritional uptake by the plant, and it improves photosynthesis. At this point in time, having a balance of water and oxygen, there's no downtime by the plant. Now, post-harvest, we're very familiar with very dry soils. At this time, we're looking at high tension numbers, a high deficit. At 800 kPa, we start to see a lot of our nutrition program come out of solution and start to precipitate out. At this point, you can see in the example to the left at 800 kPa, we're beginning to see salts accumulate outside of that soil profile. At 500 kPa, it kind of resembles a little bit more of like a blue groove that you would have on a road, where yes, there is moisture present in the soil, but it has that snap. It has that ability where it's compacting. It's just really not available to that plant. And you can really see it as far as looking at the canopy. You're seeing leaf curl, you're seeing reduced turgor pressure. Overall, the canopy is stressed because of a lack of water availability due to high tension and low water availability. Post-harvest, most soils are going to be extremely dry. But what do you do when you get to this situation? How do you rehydrate a soil that's completely desiccated out? And what we really have to do is we have to come back to the fundamentals. What is your application rate? What's your tension deficit? What's your available water holding capacity of that soil? How many hours can you apply? And how many irrigation sets do you have to get around? Well, in this application, it's a double line drip almond orchard. which applies 0.04 inches per hour. Looking at our tension data, we see that all three monitored soil tension depths are above 800 kPa. Using Web Soil Survey, we can assess that this soil profile within a 36-inch soil profile can accumulate up to 3.2 inches of water. Comparing that to our application rate, we'd have to apply at least 80 hours of water to rehydrate that. But guess what? We have limiting factors with water infiltration, water penetration, as well as topography, which can compromise or essentially limit the amount of hours that we can apply. Before harvest, this field was able to receive 14 hours of water before we saw runoff. So there's absolutely no way that we can apply 80 hours of water just straight through. We would see runoff, excessive issues. And overall too, it has three sets. There, as far as for this field, this pump has three valves. You can't have another field be off of water for 80 hours and the other one off of water for 160 hours just to get water to it. It's in a timely manner. What we're trying to do is we're trying to maximize our uptime. Now, looking at our first irrigation with this orchard, it was for 15 hours. At that point in time, soluble gypsum was injected and we were able to get water down to 24 inches. And what we're trying to do is we're trying to make sure that we're mitigating our runoff with this field. At this point in time, water began to run off, and that's where our limiting window was. Now, comparing our first to our second irrigation, we're really making sure that we're maximizing our uptime. If we know that we have rehydrated up to 24 inches of soil, we want to make sure that that tree is utilizing that water before we reapply it. In this situation, we were able to apply another 18 hours of water by injecting soluble gypsum into the drip hose. At that point in time, we allowed basically the soil was able to rehydrate down to 24 inches. But that window between August 28th and September 2nd, what we're seeing is that the tree is utilizing that water before we reapply more. Now, looking at our rehydration, this rehydration took 2 weeks. At this point in time, 66.5 total hours were applied to rehydrate the root zone and meet the weekly water demand of the trees. Irrigations were timed around uptime. If we look at this graph on the very bottom, we see that the trees go from being wet. We let that top 2 feet get a balance of water and oxygen before smothering it with more water, and we strategically keep applying more water. At this point in time, we have 0 leaching hours and we have a full soil profile. Now, not every field is going to have a perfect deficit where everything's dry. There's going to be a lot of variables. Now, with a variable dry down, we really need to look at where our deficit is in really looking at our soil types. In this example, we have a clay loam that's down to about 16 inches. The field transitions to a silt loam, and towards 36 inches, it actually goes to a sandy loam. We're looking at soil structure changes. We're looking at root mass and root surface area. Where are our roots? Are the roots predominantly in the topsoil? Are they predominantly throughout the median area? Really looking at where these variables are, as well as looking at what previous irrigations have provided for these trees before we get here. The previous irrigation after the Aldrich harvest still have water at 3 feet, and we have a moderate amount of water at 24. With this field, it's a micro sprinkler application that puts out 0.043 inches per hour. As I said before, we have a high soil moisture deficit at 12 inches, a moderate soil moisture deficit at 24, and we have a low deficit at 36 inches. The available water holding capacity of this field is just over 6 inches, and we know that we can apply 24 hours of water before we start to see ponding or any type of runoff. After Monterey harvest, bulk soil amendments were broadcasted to help incorporate with that first irrigation, as well as help reset any type of issues that we have with water penetration. When the irrigation was ran, water was pulled off to minimize standing water and also move it to the other irrigation set. Overall total time was just under 24 hours. Now, there are great benefits to these multiple irrigations for soil rehydration. And what we're trying to do is we're trying to eliminate runoff. Simply knowing that you need to apply 4 to 8 hours, but you're going to see 12 hours of runoff and it's going to go into your neighbor's place. It's really eliminating your irrigation efficacy, as well as making sure that water and nutrition are staying on the field. We're improving our irrigation efficiency, and we're also reintroducing oxygen into the soil. Simply having soil sealed off for days on end isn't going to be beneficial for those top surface roots, those fibrous roots, for uptime. Overall, we're trying to improve water distribution uniformity. If we know that we are having runoff issues, we want to make sure that it's not running off into the lows, it's coming off of the highs, and where you start to see a variable of the application itself. Looking at our second irrigation, water did reach 3 feet, and it's rehydrating the taproot. Runoff and leaching fractions were eliminated by simply splitting the irrigation application into 2 applications. At this point in time, we're going to maximize our uptime as well as minimize any potential for nutritional loss. Now, after we've hydrated our soil profile, we really need to look at maintaining basically the soil profile until dormancy. So this maintenance irrigation plan, what we're trying to do is we're trying to make sure that we're matching the field water demand and that we're not excessively applying water and creating mud. We're trying to really make sure that we're mitigating excessive stress, and we're evaluating our canopy maturity and percent foliage. Within your irrigation management plan, you're also tracking temperature changes and trends. Now, when looking at this Pinot Grigio after harvest, we ran into lower temperatures as well as a lower vapor pressure deficit, where 4 hours of water were able to maintain these vines. What we started to see is that with more water applied with these longer irrigations, we started to see that the vines root zone became saturated, and we saw a lot less water uptake at this point in time. Getting the vine too wet definitely compromised its ability to function. Now, looking 2 weeks ahead this year, we see that we have a hot 2 weeks. We still have a really well-supported canopy, and that the vines are actually requiring 8 hours of water during these high temps and a high vapor pressure deficit. We see minimal downtime with a balance of water and oxygen. By looking at this, we see strong heartbeats through our soil tension profile in a relationship of time, as well as during this hot spell. I'm making sure I'm not over applying water within this top 12 inches. If we look at this, we're trying to make sure that we're not excessively applying water to that 12-inch soil profile. The vines aren't supporting any type of fruit. You have to make sure that you're not getting them too wet. In this case, we're allowing that top 12 inches to dry up a little bit before we reapply water. Now, looking into November, we're seeing, even with trees and vines, we're starting to see reduced photosynthesis due to leaf maturity and age. In this Pinot Grigio, we're starting to see a lack of chlorophyll, just simply even a lack of leaf. We're seeing leaf drop. We're seeing reduced water uptake. And looking at November, we're seeing a very healthy basically uptake of water by the vines, and then it's simply hit with 9 hours of water before the district water is cut off, just to top it off, unknowns if any kind of rain is going to come through It's just simply making sure that the vines are topped off without being too wet before they go dormant. In conclusion, next year's crop relies on this year's actions. We really need to focus on time, not just simply rehydrating our soils, making sure that we're managing our water availability to make sure that things aren't getting too wet or too dry. We need to make sure that our nutrient management program is supporting our soil rehydration abilities, as well as any type of voids that the soil or plants are seeing. We need to really look into what our pest and disease pressure is and making sure that our irrigation management strategy is best tailored to those type of situations. And overall, precision irrigation is a year-round task.
All right. Good stuff, Travis. Thank you. So we did receive a few questions during the webinar. If you guys have any more questions, feel free to use the Q&A section at the bottom of your screen. You should be able to type in any questions there. Travis, I'll go ahead and fire a few questions that we got during this webinar. So the first one coming from Jeff, asking, when is the best time to apply soil amendments?
Now, as far as with like bulk soil amendments, where like such as potash or gypsum, or if you're changing any type of like your pH with sulfur, what I try to do is try to chase your pickup machine. Take advantage of those dry soil profiles to minimize compaction and apply these broadcasted materials. If the material isn't available, my best recommendation to do is to simply rehydrate the profile as much as you can in a timely manner, dry out your top 12 inches, minimize compaction, get that material on, and then incorporate it with your irrigation system. As far as with nutrients that are able to run through your irrigation system, you can start them right away. We're trying to rejuvenate these plants and make sure that we're maximizing this uptime. And we just really want to make sure that we're minimizing compaction, and we're making sure that it's within a timely manner. We don't want to put this stuff on just before the tree or the vine goes dormant.
Good. Perfect. Another question we received was from Mark. He's asking, so in your experience, when do almond trees typically stop pulling water from the soil?
And that kind of comes back to the presentation that every year is different. Mm-hmm. And I've been in a short sleeve t-shirt in the middle of November, and it was 86 degrees. And guess what? The leaves were still green. The trees were still transpiring. We were still applying water. Really looking into the rate of uptake with soil tension can let me know. It really takes away that guesswork. Now, when we were looking at that example with the vines in November compared to where they were at in September, we're seeing the slow down procedure, where the transpiration rate is becoming regulated, where that the tree or the vine is starting to slow down. But yeah, every year is different, and that's why I personally rely on precision irrigation and using soil tension to track, when our plants are going to be going dormant.
Nice. Yeah, it all makes sense. Good. And then I think we might have one more question, unless some more come in. So from Craig asking, knowing that many districts shut the water off early November, how do you plan for post-harvest irrigation in late November?
Wow, this is a good question. So I think we all get the letters of when our district is going to be cutting water off to make sure that they can maintain the supply, your canals and any type of projects that they're going to have before the rain really hits. What I'm looking at is how full is my soil profile. If I have a full soil profile, I'm not going to simply apply water at the last day that I can, because what's going to happen is that I'm going to slow down that nutritional uptake. I'm going to slow down the transpiration rate. If it's, the last thing I want to do is put my trees or put my vines to say, put them to bed wet. It's just not going to work out well. Now, if I have a deficit still come this last week before the water gets shut off, what I'm trying to do is strategically get through these irrigation sets for these specific ranches to apply enough water to kind of reach that field capacity or slightly above it, where I'm not getting the full saturation, but I'm getting that nice kind of average across the overall profile before that water's taken away. And simply not putting my trees or my vines away too dry.
Mm-hmm.
But yeah, it's every year is different,
Yeah.
and having precision irrigation in that field, you can look through. It might be dry on the topsoil, but guess what? 4 inches down and 4 feet down, it's completely saturated. So it wouldn't make sense to go put 24 hours of water on it when you know that's going to compromise those roots.
Yeah. All right. Perfect. Well, thanks. Thanks a lot for your input. I think super valuable, and especially we're right in the middle of it right now. So very good stuff. All right. Well, I think that's gonna wrap it up. If you guys have any questions you want to ask, we're gonna leave the webinar on for a few more minutes, maybe 10 minutes or so, and
Okay.
feel free to put in your questions in the Q&A or in the chat box, and we can probably reach out to you directly if you have any questions. We'll also have our Travis and I's contact information on the final slide. Feel free to reach out. We can answer some questions. Other than that, I'll wish everyone a good day and a good rest of harvest for our growers in California.
That's
Thank
good.
you, Travis.
Hey, thanks for bringing me in, Nick. I appreciate
Yep.
it.
You're
Thank you.
welcome. Thank
Bye.
you. Bye-bye.